Welcome. Today's lesson is on geometric sequences. Again, a sequence is a string of numbers that might or might not have a rule that relates how to go from one term to the next. So these are a term of a sequence. Now, if a sequence happens to have a common difference, in other words, you're adding the same amount, it's called an arithmetic sequence, which was the last lesson. This one is a geometric sequence. A geometric sequence, you're either multiplying or dividing as you go through the sequence of numbers. Now, we technically want to avoid division, so rather than dividing, we actually multiply by a fraction. And we'll get to that in just a minute. But this one, the easiest way to find what you're multiplying by in geometric sequences is take any two consecutive terms, it doesn't matter which two, take the one on the right and divide it by the one on the left of it. So 4 divided by 1 is 4. That tells us that we are timesing by 4 as we progress to the right in our sequence. 4 times 4 is 16. 16 times, not add, times 4. 16 times 4 is 64. 64 times 4 is 256. Now, it would be nice if you had a calculator handy for these bigger numbers to grab a calculator, like I'm grabbing one right now, to do 256 times 4. 256 times 4 gives us a 1024. Now, geometric sequences get big really fast if your ratio that you're and they, by the way, they call that a common ratio. The ratio, as you move from one to the next term, they get really big really fast if it's larger than 1. So here it's kind of hard to see what we're multiplying to get to here, but again, you take any two consecutive numbers, take the one to the right of the two numbers and divide it by the one on the left, and we find out what we are multiplying by. 1,296 divided by 216 would be 6. And so I come back here to verify. I times by 6, that's 36. If I times by 6, I better get 216, and lo and behold, I do. Times by 6 is 1,296. Times by 6 is 7,776. So I'm multiplying by 6. Moving on here, one thing I want to emphasize about geometric sequences can alternate between positive and negative numbers because we're multiplying. When you multiply by a negative number, it changes the sign of the original number. If it was originally positive, it would become negative. If it was negative, it becomes positive. So again, here, I'm just going to take these first two consecutive numbers, negative 25, that's the one on the right, divided by the one on the left, gives me a common ratio or multiple of negative 5. So I times by negative 5. If I times by negative 5 again, it goes from negative to positive. So I get 125. If I times by negative 5 again, I go back to a negative 625. If I times by a negative 5 again, I go back to positive. So these geometric sequences can alternate between positive and negatives. But they don't have to alternate, obviously. They can stay completely positive, or they can stay all the time negative. In other words, I'm missing my first term here, so I'm going to use these second two terms to see what my common ratio is, or what I'm multiplying by. So I take the one to the right of the two I'm looking at, and I divide by the one on the left of the two I'm using. And negative 36 divided by a negative 12 is a positive 3. So I'm actually multiplying by 3 as I go to the right, times 3, times 3. And since I'm multiplying by a positive number, it's not going to change the sign. That's why it will always stay negative. Now just be careful. If you're looking for a term that's in front of some term, by multiplying to move to the right, I would be dividing moving to the left, or multiplying by 1/3, the reciprocal of this. And that's what I actually like to think of is going this direction. I'm multiplying by That's supposed to be 1/3. And anyway, 1/3 of -12 would be -4. And yes, then we would get into fractions and decimals, but there's nothing wrong with fractions and decimals. So let's look at some fractions. In general, most geometric sequences will be shown to you as fractions. 1/58, 1/29, 2/29, 4/29. Now, the process of finding what we're multiplying by is no different. I take any two consecutive terms. Let's do the first two. I take the 1/58 and the 1/29. I take the one that I'm looking at on the right, 1/29, and I divide it by the one on the left. Now we might need to go back to elementary form of division where I take the 1/29 divided by 1/58. And how do we divide by fractions? Well, we keep the first one the way it is, 29. We change the division to times, and we flip this one, 58/1, and then we multiply straight across, 58/29, and then if we can, reduce. By the way, 58/29 is 2. So what I'm doing is I'm timesing by 2 moving forward, which when I multiply this first fraction by 2, it actually reduced the denominator to 29, or simplified. Then I times by 2 again. And again, I like to think of it as a fraction. I'm timesing by 2/1, timesing by 2/1, timesing by 2/1. So when I get to this unknown value, times it by 2, times it by 1, oh, I get 8/29. And again, you notice the denominator quit changing because I'm actually only multiplying by a whole number. Let's look at this one. Again, here the denominator's changing. The numerator's staying the same. So it looks a little different, but again, the process is the same. We take any two consecutive. I could take these two if you wanted, or these two. Let's take these two. If I take these two, again, I'm going to take the one on the right, 1/40, and I'm going to divide it by the one to the left of it, 1/20. Now again, I keep the first fraction the way it is. I change the division to times. I flip the second fraction, and then I get 20/40, but that reduces to 1/2. So again, I don't want to think that I'm dividing by 2, but that's what I'm doing. I like to think of it as I'm timesing by 1/2, timesing by 1/2, timesing by 1/2. So if I times this by 1/2, I get 1/80. Let's do just a couple more, then we'll be done. So again, 2/3, 1/3, 1/6, 1/12. Again, the denominator is what's changing, but I still look like I had the numerator change once. But again, I take any two consecutive terms, take the right one, and I divide it by the left one, which means I'm going to take 1/3 and times it by 3/2, and I find out that I'm, just like the previous geometric sequence, I'm timesing by 1/2. So if I times by 1/2, that next term would be 1/24. Here, again, this looks like, oh wow, the numerator changed again. Can this really be geometric? The denominator is always changing. It can be. Again, I'm going to take two consecutive terms. I'm going to take these easiest two, these two middle ones. I'm going to take the 1/3, which is the right one. I'm going to divide it by the left one, which is 1/2, which means I have 1/3 times 2/1. I'm multiplying by 2/3. Let's see if it actually works. What is 3/4 times 2/3? Well, it would be 6/12, but what's 6/12? That's 1/2. What's 1/2 times 2/3? Well, that would be 2/6, but 2/6 reduces to 1/3. What's 1/3 times 2/3? Well, 1 times 2 is 2, 3 times 9. It worked, 2/9. So the next one, again, I'm going to multiply by 2/3. 2 times 2 is 4. 3 times 3 is 27. So the next term would be 4/27. Hopefully this allows you to accomplish today's lessons. If you have questions, please bring them to class.